So this is some work we did with Unity on making sure that if you're running models within Unity and Unity Sentis, you can use quantization to really get some acceleration or improvements in your model. So we've been talking about AI in games a lot. It's been finding its way into games. There's this example. Koki, who just spoke, we showed this last year. Each of these rabbits are all controlled by a separate AI agent, but there are some other things too. Upscaling, depth estimation. This is the example I'm using for this talk. Depth estimation, useful as a foundation for, well, used as a foundation for AI applications. You need to estimate the depth before you can start working out where all your planes are and building up from that. And large language models as well, if you really want to go crazy. So as Koki hinted before, these models are getting more and more larger and more capable, so I want to make the most use of them. And just to point out that if you don't know what Sentis is, it's Unity's neural engine so that you can run all these AI models in-game, just inferencing them and use them for whatever task you think you want to use them for. So the trend, this is model size over time. All these dots are about 500 of the most prominent papers, models I managed to find. And they're getting bigger. This is a log scale, so they're getting a lot bigger. And we want to fit them on a mobile device. So we have a problem, really. These models are very large. How do we fit them on? So they're very large, and while they give better outputs, we kind of have to pay the cost. Disk space, got to fit in memory, and then where we run it, we've got to fit there as well. And that's 3 times you're paying the cost. And if you're on mobile, well, this is also going to cost power as you transfer between all these different levels. We're competing with the rest of the game for resources. If you want to run on a GPU, you can have an argument with your graphics people about how much space can I steal from you. And this is tactical on mobile. We have limited resources on mobile, but we still want those high quality models to give us nice output, makes a good game. So quantization is a very good solution for this. Models are trained and provided in 32-bit floats, and this precision is kind of over the top. We can quantize these down much smaller, 16-bit weight, 16-bit floats, half the size there, 8-bit integers, quarter of the size. Very helpful. The way you do it comes in several different flavors. I have a talk later where I can go into that in more detail. And Sentis, what we've been working with them is to make sure that you can quantize those models and run them in Unity. So this is sort of an example of the output that you get from a quantized model. So Midas is a monodepth model, just simply estimates depth from the camera. Here, red is close, blue is far away. So if that's your input, that's your output for a 32-bit model. You know, maybe you can say that the beans aren't showing up correctly, but that's the model's problem. The 16-bit floats, this is a difference between those two images, and there's basically no difference. Here, 8-bit integers, maybe you might be able to see the difference there, and some around there. There is a trade-off that you can make, but maybe you don't need that quality. Sometimes you can mask it in a game. These are things like LLMs. Maybe that just means it generates something slightly different but still makes sense. So Sentis provides both of these as options. You have to make a choice, but that's a trade-off that you need to consider. So if you want more of this, I have a talk later on in the West Hall. I'll go into much more technical detail, give a few more examples. And thank you all for listening. As people have said before, check out the ARM Development Hub, lots of resources there. And we have some tools, and we have some cool demos around the back here. There's an LLM running on a mobile device. Thank you.